we have been spending most of our time with Laplace transforms, computing them for various functions. Now we want to spend a moment building up some more of our theoretical infrastructure. In working with Laplace transforms and differential equations in general, we often have more than one term involved. So we want to be able to compute the Laplace transform of a linear combination of functions. In other words, if we have functions f1 and f2 with constants c1 and c2, we want to be able to compute the Laplace transform of the linear combination of these functions c1 times f1 of t plus c2 times f2 of t. Like when we were computing Laplace transforms of other functions, we will start using our definition of the Laplace transform, that the Laplace transform of a function is the integral from 0 to infinity of e to the negative st times our function dt. Just now our function is the linear combination c1 times f1 plus c2 times f2. Now we've written this as an integral, and due to the linearity of integrals, we can rewrite this as c1 times the integral from 0 to infinity of e to the negative st times f1 dt plus c2 times the integral from 0 to infinity of e to the negative st times f2 dt. But remember, for this to be true, we need both of these improper integrals to converge. And in the case that they do converge, we simply have here c1 times the Laplace of f1 of t plus c2 times the Laplace of f2 of t, since the integral from 0 to infinity of e to the negative st times f1 of t dt is the Laplace of f1, and similarly that integral for f2 is the Laplace of f2. Now let's come back to this issue of convergence. Remember, both of these improper integrals converge for values of s where the Laplace transform of f1 and the Laplace transform of f2 exist. So if we can find the values of s where both of these Laplace transforms exist, then we know both integrals converge there. In other words, if the Laplace transform of f1 exists for s bigger than s1 and the Laplace transform of f2 exists for s greater than s2, then we want to know the values of s where both of them exist. But as long as s is bigger than both of them, in other words, s is bigger than the max of s1 and s2, then both Laplace transforms will exist and both improper integrals will converge. That is, both improper integrals converge for s bigger than the max of s1 and s2. And thus, the Laplace transform of c1 times f1 plus c2 times f2 will be equal to c1 times the Laplace transform of f1 plus c2 times the Laplace transform of f2, so long as s is bigger than the max of s1 and s2. This linearity property will prove to be incredibly useful when solving differential equations using Laplace transforms.